Rationalization of binomial surds, conjugate surds. An expression may contain two terms, for example, 6 minus root 5, 3 root 2 plus root 3, 2 root 3 plus 4. If one or both of the terms contains a surd, we call this a binomial surd expression. To rationalize a binomial surd expression, we use the idea of the difference of two squares. For example, to rationalize root a plus b, we multiply by root a minus b to get root a squared minus b squared, which is a rational number. So root a plus b and root a minus b are said to be conjugates of one another. So now the idea of conjugate surds is that when we come across a surd, which first of all, a surd that is binomial in nature. Binomial we mean that the surd contains two terms. The first lesson under division of surds, in order to divide 2 root 3, we needed to rationalize this. This is an irrational number, root 3, and for division or for simplification to be possible, we needed to simplify this to a rational number, and for us to do that, we had to multiply both the numerator and the denominator by the denominator, which is root 3. In that way, we got 2 root 3 over 3 times root 3, which became 3. So our denominator was rationalized. So the denominator initially was irrational. Now after this process, it became a rational number. So that's the idea of rationalization of surd, when you rationalize it, because initially it was irrational, then it underwent a process, became a rational number. So in this case, a rational number. But when in this case, it's a single surd. But when a surd contains more than one term, which in this case is two terms, we call it binomial surd. Now, binomial surds also have a way that they need to be rationalized. For instance, if you have a surd like 3 root 2 plus 4 over 3 root 2 minus 4. This is surd, numerator and denominator. For the denominator, the surd contains two terms. This is the first term, this is the second term. Some cases you may have 4 root 3. So whether it's 3 root 2 minus 4 only or 3 root 2 minus 4 root 3, discover that it has two terms, so we call it binomial surds. Now, how do we go about simplifying binomial surds? We also use the process of rationalization, but in this case, we don't just rationalize just as we do if it were a single surd. Now, for us to be able to make this binomial surd a rational number, we need to implement or use the idea of difference of two squares. That brings us back to what difference of two squares is. Now, note here, let's take our notes first of all. Two surds are said to be conjugates of each other if their product gives rise to a rational number. So two surds are said to be conjugates. I just mentioned the conjugate, the two surds being conjugate of each other, and that for us to rationalize a binomial surd, we need to use the idea of difference of two squares. So how do we ensure that two conjugate surds their products give rise to a rational number? So from our knowledge of difference of two squares, we know that a plus b, a minus b is equal to a squared minus b squared. Similarly, root a plus root b, root a minus root b will give us root a squared minus root b squared, which is equal to a minus b. So by the time we carry out, or by the time we use the idea of difference of two squares on binomial surds, we are going to get our final result to be a rational number. Let's take, for instance, a plus b, and a minus b. This is popularly known as difference of two squares, where for the first bracket, the sign is plus, the second bracket, the sign is negative. So just expand this. A times a is a squared, A times minus B is minus AB, plus B times A will give us plus AB, and plus B times minus B will give us minus B squared. Minus AB plus AB will cancel out because minus something plus another thing, just like minus AB plus AB. I have one apple plus AB, which I have minus this I borrow. So if I give what I have to the person I am owing an item, would I have anything left? No. So minus AB plus AB will cancel out to give us 0. So what will be left is A squared minus B squared. So this is why we have this here. Similarly, if you carry out the same thing here, root A times root A will give us root A squared, which is root A squared here. Root A times minus root B will give us minus root AB minus root AB. Then root B times root A will give us plus root AB. Now, of course, you see minus plus, and the coefficient is 1, and here also is 1. So minus 1 plus 1, minus 1 with AB plus 1 with AB will give us 0. Then we'll be left with root A squared minus root B squared. And of course, root B squared, root A squared minus root B squared. This will cancel this, this will cancel this. What is left is A minus B, which is what we have here. So now you discover that since this was our surd, the binomial, this is difference of two squares. If this was our surd root A plus B, which was the denominator, by the time we use the difference of two squares, and by that we multiply it by its conjugate, which is root A minus B, we discover that at the end of the day, both of them were irrational, but our final result, which the result of the product of the surd and its conjugate, is a rational number. So that's how we carry out rationalization of binomial surds, by using the idea of difference of two squares. So if the denominator of a fraction is a binomial surd, always take note, it's not the numerator, it's the denominator we're always looking at. So if the denominator of a fraction is a binomial surd, use the conjugate of the denominator to rationalize it. Use the conjugate of the denominator to rationalize it. The question then is, how would you know the conjugate of a surd? Well, the conjugate of a surd is, if a surd, for instance, is root A plus B, the conjugate would be you just change the sign between the two surds. That will give you the conjugate. So that will give us root A minus B, such that when you multiply these two together, the product of these two surds will give you a perfect, will give you a rational number of this form, A squared minus B squared. If it gives you this form, and then eventually, it gives you this form, then you know that your answer is correct. So that's the conjugate. And in this case, when the surd is 3 root 2 minus 4 root 3, the conjugate would be these same terms, but opposite sign, which is 3 root 2 plus 4 root 2. So that's the conjugate. So to get the conjugate of a particular surd, just change the sign. The other bracket will have the same terms, but the opposite sign, and it's usually between minus plus or plus minus. So that's all there is. So further examples, or the examples I'm going to take from this point on, will show how the knowledge of this is essential. We'll be using that what I've explained here to carry out simplification of binomial surds. So question says, by rationalizing the denominator, simplify each of the following. So our simplification is going to take place through the process of rationalization of the denominator. And in this case, the denominator is a binomial surd. So how do we rationalize a surd with denominator that's by the denominator is a binomial surd? We do that by multiplying both sides by its conjugate. So the conjugate of this is what we are going to use to multiply both sides. So this will give us 3 plus root 2 over, I'm going to put it in brackets, over root 5 plus root 3. Now the conjugate of this will give us times root 5 minus, since it's positive, the conjugate will be negative for the same terms, only the sign that will change, over root 5 minus root 3. So what you observe is that for the denominator part, this is already difference of 2 squares. So that's what you're going to get once you multiply both sides by its conjugate. So already this part is the difference of 2 squares. So at the end of the day, you're going to have root 5 squared minus root 3 squared. So let's simplify here. This will give us 3 times root 5 will give us 3 root 5. And same theory to multiply here. 3 times minus root 3 will give us minus 3 root 3. And plus root 2 times root 5 will give us plus root 10. And plus root 2 times minus root 3 will give us minus root 6. And then this will give us over root 5. From difference of 2 squares, this will give us root 5 squared will give us 5 minus root 3 squared will give us 3. 5 minus 3 is 9, like it here. 5 minus 3. So the answer will be, which is equal to 3 root 5. 3 root 5 minus 3 root 3. So we don't have similar roots. So the answers are, okay, so that will give us 3 root 5. Just leave it like 3 root 5 minus 3 root 3 plus root 10 minus root 6 over 2. And you can also leave it like this. Since this is the denominator, you can bring it like this: 3 root 5, 3 root 5 minus 3 root 3 plus root 10 minus root 6. It's simple. You can leave it in this form, or you can leave it in this form. That's A. So B, 2 root 2 plus 3 root 3 over 4 root 3 minus 2 root 2. So if you are going to simplify this, then we need to rationalize this expression by multiplying both sides of this expression by the conjugate of the denominator. And the conjugate is 2 root 3 root 3 4 root 3. Since there is negative, then the conjugate will be plus 2 root 2 over 4 root 3 minus 2 root 2, 4 root 3 plus 2 root 2. And this will give us 2 times 4 is 8. 8 root 2 times root 3 is 8 root 6. 2 times 2 will give us 4. 2 times root 2 is 2. 2 times 4 is equal to 8. That's plus 8. 3 times 4 is 12. Root 3 times root 3 is root 9, which is equal to 3. So 3 times 12 is 36. 36. 3 times 2 is 6. 6 times root 3 times root 2 will give us root 6. That's 6 root 6 over. Here we can simply carry out the difference of 2 squares by saying 4 root 3 times 4 root 3 times 4 root 3 squared, and just saying 4 root 3 squared. Just pick this and square this. That's 4 root 3 squared minus, then pick the second term, 2 root 2 squared, which will give us square of 4 will give us 16, and root 3, square of root 3 will give us 3. That's equal to 48 minus square of 2 is 4, and root 2 square of root 2 is 2. 4 times 2 is 8, so it gets 14. Or we can also expand. So 4 times 4 is 16, and root 3 times root 3 is 3. 3 times 16 is 48. 4 root 3 times 2 plus 2. 4 times 2 will give us 8. Root 3 times root 2 will give us 6. So that will give us plus 8 root 6. And then minus 2 times 4 will give us minus 8. Root 2 times root 3 will give us root 6. So minus 8 root 6. Minus 2 times plus 2 will give us minus 4. Root 2 times root 2 is 2. 2 times minus 4 will give us minus 8. Now, plus 8 root 6 minus 8 root 6 will cancel out. So this will give us 8 root 6. 8 root 6. Okay, let me write this out first. So 8 plus 36 will give us 44. 44 plus 8 root 6 plus 6 root 6 over 48 minus 8. And this will give us 44 plus, okay, so 44 plus 8 plus 6 will give us 14. 14 root 6 over 48 minus 8 will give us 40. So when you simplify further, this is a common denominator. That tells you that it's 44 over 40 plus 14 root 6 over 40. So 44, what can go? 4 here, 11, 4 here, 10, 2 here, 7, 2 here, 20. So this will give us 11 over 10 plus 7 root 6 over 20. Either you do your answer like this, or you look for a common denominator. If you look for, if you simplify it, you're going to get to this form. But if you from this form, you simplify it further to get to this form. So to get to this form, you look for the LCM of the two denominators. Then you know what to do. You get to this point again. So this is our final answer. So either this or this is correct. C. 1 plus root 5 plus root 5 over 1 minus root 5. And this will give us 1 plus root 5 1 minus 1 plus root 5. Multiply both sides by the conjugate of the denominator, which is plus here. So 1 minus root 5 and 1 plus root 5. And this will give me, so 1 times 1 is 1 plus 1 times root 5 is root 5. Root 5 times 1 is root 5. And root 5 times root 5 is 5. Now here, I'm going to take the difference of 2 squares. So 1 squared is 1. 1 minus root 5 squared is 5. So 1 plus 5 is 6. Root 5 plus root 5 is plus 2 root 5. 1 minus 5 is minus 4. This will give you minus 1 over 4 bracket 6 plus 2 root 5. That was my final answer. So this is my final answer. So this is my final answer. I can see simplified for that. I'm going to say or. So from here 6 plus 2 root 5 over minus 4 is equal to minus 6 over 4 plus 2 minus, so this is plus so plus 2 get minus 2 over 4 root 5. Okay, you know that plus times minus will give you minus, definitely. So 2 here 2, 2 here 2, 2 here 1, 2 here 2. So this is equal to minus 3 over 2. Plus times minus is minus minus 3 over 2 minus root 5 over 2, which can also be, since they are the same LCM, since the LCM are the same, let's say minus 1 over 2 minus 1 over 2, and then you have 3 plus root 5 over 2. You can either this or this, simplify. We express 8 minus 3. 8 minus 3 root 6 over 2 root 3 plus 3 root 2 in the form n root 3 plus n root 2, where m and n are rational numbers. So now that we're starting with what we're given here, we don't need to concern ourselves with what m and n represent here. M and n will be the final result of this simplification. So let's simplify this expression. So this will give us 8 minus 2 root 6 times the conjugate of this binomial surd 2 root 3. Since it's plus, the conjugate is minus 2 root 2 over 2 root 3 plus 3 root 2 multiplied by its conjugate, 2 root 3 minus 2 root 2. 8 times 2 will give us 16. Now give us 16 root 3. 16 root 3. 8 times minus 3 will give us 24. It's minus 24 root 2. Minus 3 times 2 give us minus 6. And root 6 times 3 will give us minus 6, 18. Minus 6, 18. Root 18 rather, minus 6 root 18. So minus 6 root 18, let me put it here. So minus 3 root 6 times 2 root 3. And 3 times 2 will give us minus 6 times root 6 times root 3 will give us root 18. But we need to simplify this further. Minus 6 times root 9 times 2. Minus 6 times root 9 is 3 times root 2. Minus 6 times 3 will give us minus 18 root 2. So you'll get minus 18 root 2. So minus 3 times minus 3 is plus 9. Root 6 times 2 will give me root 12, same thing here. So minus 3 minus 3 will give us 9. So 9 times root 6 times root 2 will give me root 12. So 9 times 4 times 3. So 9 times root 4 is 2 times root 2. So 18 root 3. This will give me plus 18 root 3. So now we're going to get this is the difference of two squares. So that will give me 2 root 3 squared minus 3 root 3 squared. 2 root 3 squared is 2. The square of 2 is 4. The square of root 3 is 3. 4 times 3 minus the square of 3 is 9. The square of root 2 is 2. 9 times 2. That's 12 minus 18. That's minus 6. Here is minus 6. So 16 root 3. Bring similar sorts to group similar sorts together. 16 root 3 plus 18 root 3. Then minus 24 root 2 minus 18 root 2 over minus 6. And this will give us 16 root 3 plus 18 root 3. 16, 18, 8 plus 6, 14, 1 plus 1, 2 plus 1, 34. That's 34 root 3, 34 root 3, and then minus 24 minus 18, 24 minus 24 minus 18. When the signs are the same, you add them together. 4 plus 8, 12, 2 plus 1, 3, 42, minus 42, minus 42 root 2. And that's over 6. Okay, so so this gives us 34. Because it's minus here, so minus 34 root 3 over 6. And also here minus 42 over 6 root 2. So 2 here, 17, 2 here, 3. 6 here, 1, 6 here, 7. That's equal to minus 17 over 3 root 3 minus 7 root 2. So from what we have here, this is our final answer. Now the question says express 8 minus 3 root 6 in the form 2 root 3 plus 3 root 2 m root 3 plus n root 2. Okay, in the form m root 3 plus n root 2. So what we have here is minus 17 over 3 root 3 minus 7 root 2. So take note, we have a positive sign here plus n root 2. So here is positive, and what I have here is negative. That means I omitted something while calculating. So okay, I found it. So here we have minus 42 and minus 6. So when I split this combined expression to the partial fractions, this is minus, since there's negative, this minus here was what we have here, minus 6, and this minus was originally here, this minus 42, and here is minus 6, so it's supposed to be minus 6 here. So minus cancel out minus, so you have it plus 7 root 2, and that's plus 7 root 2. So now we can compare n root 3 plus n root 2. So this is minus 17 over 3 root 3 plus 7 root 2. So here, if you compare this, minus 17 over 3 is our n, and 7 is n. So we say where n is equal to minus 17 over 3 and n is equal to 7. So these are final answer, and this compares to what was given to us. Number 2, express 1 root 5 plus root 3 in the form p root 5 plus q root 3, where p and q are rational numbers. So I forgot to add, like in number 1, where this statement says n root 3 plus n root 2, where m and n are rational numbers. So of course, you can see that our m being minus 7 over 3 is a rational number, and our n being 7 is a rational number. So this is exactly what we're going to get after we are done with simplification. But that doesn't mean that our p would also look like this or like that, but it's just that the final result, whatever p or q would represent, would be a rational number. So let's simplify this. We're going to do this by, okay, let's see. 1, the conjugate of this would be 1 times root 5 minus root 3, and this will be root 5 plus root 3 root 5 minus root 3. And here is root 5 minus root 3. So difference of two squares, root 5 squared minus root 3 squared, root 5 minus root 3 over 5 minus 3. And this will give us root 5 plus root 5 minus root 3 over 2. Since the is a common denominator, we can split it. We become root 5 over 2 minus root 3 over 2. So from here, what's our p? So our p is 1 over 2 plus 1 over 2, and our q is minus 1 over 2. So we can write that as 1 over 2 root 5, 1 over 2 root 5 minus, okay, minus root 3. Yeah, we can simplify it this way, 1 over 2 root 5 minus root 3. So from here, our p, which must be a rational number, is plus 1 over 2, because p here is positive, plus 1 over 2, and our q, which is for root 3, is yes, minus 1 over 2. Let's write that where p is 1 over 2 and q is equal to minus 1 over 2. So that's what we expected to do. Number 3, simplify 5 3 plus root 2 minus 2 3 minus root 2. Giving your answer in the form a plus b root n, where a, b, and n are constants. Constants are rational numbers, so either if you don't see rational numbers, you are going to see constant. They mean the same thing. Now, this particular example is different from these ones and these ones. What we have here is an expression. This is a fraction, while here we have this is a fraction. Here we have two different fractions, 5 over 3 minus 2 and 2 over 3. So 5 over 3 plus root 2 minus 2 over 3 minus root 2. As when you look at it, you can see that this one is different from this. Here we have a single fraction, and here we have two fractions separated by minus. So what we're going to do, we're going to apply the principle of fractions, simplification of fractions. So if you have, let's say, 3 over x minus 1 plus, or let's say minus 2 over x minus 2, what do you do? To simplify this fraction, we need to look for the LCM. The LCM will be the denominators, the product of the two denominators, which is x minus 1 and x minus 2. And then when we divide the LCM, divide the denominator by the LCM, x minus 1, x minus divided by this LCM, this part will cancel this part because they are common. So you'll be left with this part. So you have the 3 x minus 2 minus, and do the same here. This will cancel here, and you will be left with this. So this will be 2x minus 2. Then open your bracket and you simplify. That's how you simplify fractions of that nature. So take note, this particular surd is different from this particular one. So the process of simplifying this particular type of surd is different from the process of simplifying this. In this case, you rationalize it by binomial surd, but in this case, you simplify it as though you are simplifying a fraction of this sort. So let's get the LCM. So the first the LCM of the denominators. The LCM of the denominators. LCM of the denominators is 3 plus root 2 and 3 minus root 2. We use our LCM to divide the denominators and then multiply by what we have as the numerator. So let's write out LCM down. Our LCM is 3 plus root 2, 3 minus root 2. So this part divide the denominator. You're going to have this, since this part is common to this part, will cancel. So this part will be less. So 3 minus root 2 times 5 will give us 5, 3 minus root 2, and minus the LCM to divide the denominator. So these two parts are common, so they will cancel out, and then this part will multiply this. That's 3 plus root 2. And now we're going to, this is difference of two squares, so let's put this bracket. 5 times 3 is 15 minus 5 is 2. Minus 2 times 3 will give us minus 6. Minus 2 plus root 2 will give us minus 2 root 2. And then 3 plus root 2. Oh, sorry, this is a difference of two squares, so this will give us 3 squared minus root 2 squared. So 15 minus 6 minus 5 root 2 minus 2 root 2 over 3 squared is 9 minus root 2 squared is 2. This will give us 15 minus 6 is 15 minus 6 will give us 9. 15 minus 6 is 9. Minus 5 root 2 minus 2 root 2 will give us minus 7 root 2 over 9 minus 2 is 7. So this will give us this is our final answer, but for the sake of what we have here, it says leaving your answer in the form a plus b root n, where a, b, and n are constants. So this will give us simplify, so this is equal to 9 over 7 plus, let's see, Let's factorize this. 7 is common. That will give us 1 over 7. 1 over 7 over 9 minus 7 root 2. Okay. And so in this case, we are saying that since it must conform to what we have here, a plus b, we're going to say where e is equal to 1 over 7, where e is equal to 1 over 7, where e is 9 over 7, yeah, where e is 9 over 7. Before I get to this, let me even simplify here. So this gives us 9 over 7, and here is minus 7 over 7. 7 over 7 root 2, so 7 will cancel, so that will give us 9 over 7 minus root 2. 9 over 7 minus root 2. So where a is 9 over 7, so here is root 2. Here is 9 over 7, and b equals to minus 1. So minus 1, here is plus, but still minus 1 times plus times minus 1 will give us minus. Minus in this exact equation, in the exact solution. But here we told that it should be in the form a plus b, so it doesn't necessarily mean that your final answer will always be plus. But how you can do this is that if you rewrite this answer, you can write this answer in this form. Like, let me take from here, let's say 1 over 7, okay, equal to 1 over 7. Okay, let me start from here. Let's say 9 over 7 minus root 2. So how you can get it to conform to what you have here is that the final answer will be 9 over 7 plus minus root 2. So if you check it, you can see that it conforms to this order. So where a is equal to 9 over 7 plus, and then b is now minus 1, because here is you don't have anything, and that means it's 1, so it's minus 1 root 2. So minus 1 root 2 times plus, and I give you 9 over 7 minus root 2, which is the exact solution that you have here. Okay, so that's our answer. So our a is 9 over 7 and b is minus 1. Express the root 2 minus root 3 over 2 root 3 minus root 2 in the form root n over root n, where m and n are whole numbers. So this can be simplified by root 2 minus root 3 over 2 root 3 minus root 2. We need to apply both sides like conjugate of the binomial surd, which is the denominator. So the conjugate is 2 root 3 plus root 2, and here to the 2 root 2 plus root 2. This will give us 3 times 2 is 6, root 2 times root 3 will give us 6. 6 root 6. 3 times root 2. Nice. So root 2 times root 2 is 2. So 2 times 3 will give us 6. And that's plus 6. Minus root 3 times 2 root 3. Root 3 times root 3 will give us root 9 as 3. So minus 2 times 3 will give us minus 6. And then minus root 3 times plus root 2 will give us minus root 6. Yeah, minus root 6. Okay. And here is the difference of 2 squares. This will give us 2 root 3 squared minus root 2 squared. So that will give us 6 root 6 minus root 6 will give us 5 root 6. Okay, 5 root 6. And then, so 2 square of 2 is 4, and square of 3 is square of 3 square. The square of root 3 is 3, so 3 times 4 is 12. and then the square of 2 is 2. So this is 5 is 6 over 10. So let's go simplify the 5 here 1, 5 here 2. Let's go to root 6 over 2. That's our final answer. But the question says we should express this answer in the form root n over root n, where m and n are whole numbers. Here we don't have roots, so we say but 2 is equal to the square root of 4. So saying therefore root 6 over 2 is equal to square root of 6 over square root of 4. So our final answer, which conforms to what we were told to leave the answer, the form we were told to leave the answer in. So that's our final answer. So express 4 root 5 plus 2 root 2 over 7 root 2 root 2 plus 2 root 5. So this will give us equal to 4 root 5 plus 2 root 2 multiplied by the conjugate of the denominator, 7 root 2 minus 2 root 5, 7 root 2 plus 2 root 5, 7 root 2 minus 2 root 5. So 4 times 7 is 28. Root 5 times root 2 is root 10, 28 root 10. 4 times minus 2 will give us minus 8. And root 5 times root 5 will give us 5. 5 times 8 will give us minus 40. Plus 3 times 7 is 21. Root 2 times 2 is 2. 2 times 21 will give us plus 42. Plus 3 times minus 2 is minus 6. Root 2 times root 5 is root 10. Minus 6 root 10 over. And here will be difference of 2 squared. 7 root 2 squared minus 2 root 5 squared. 28 root 10 minus 40 plus 42 will give us 2. 28 2 plus 28 root 10 minus 6 root 10. Alright. Square of 7 is 49. The square of the square root of 2 is 2. 2 times 49 is 98. The square of 2 is 4. The square of the square root of 5 is 5. 4 times 5 is 20. So 2 plus, since the surds are alike, we can subtract. So 28 minus 6 will give us 28 minus 6, that's 22. That's plus 22 root 10 over. So 98 minus 20 is 78. So this can be written as 2 over 78 plus 22 root 10 over 78. 2 here 1, 2 here 39, 2 here 11, 2 here 39. So this is 1 over 39 plus 11 over 39 root 10. So if you are we're told to write compare, or our answer should be in this form: P plus Q root 3, where P, Q, and R are rational numbers. So if our answer is not in this form, that means it's not correct. So here we don't have any surd. So let's see. Yeah, we don't have any surd here. And then we have Q root 3. So our R is 10. So we can say therefore where P is 1 over 39. Q is 11 over 39, and R is equal to 10. So that's the final answer.